Hello, am I audible? Okay. So, hello everyone. Uh, my name is Bhavishya Pandit, and today I'll be taking a session on serial rating, which is a mini project and which will actually help you to understand machine learning and a few other concepts of the same better. So, before starting, I just like to see whether everything is like going straight on the screen. Okay. Am I audible to all? Type a yes if it is. Okay, that's great. That's great. So we'll be having a look at this mini project, which is serial rating. So like I'll be sharing the link to the data set so that you'll be able to like have a look at it too. So starting off with the basic context that we are having of this data set, I'll be sharing the link for a second so that you'll be able to. So I've shared the link to the data set in the chat section, so you'll be able to see. So basically, like this is the basic context of this data set, and it is like as the name suggests, it is like a data set of 80 serials, 80 serial products, and all of those things are here too. And you can download it from here also. And like let's start off with the basic context of this data set. So it is like first we need to see over here we're seeing the different columns that we are having, different features that we're having for that. Here we need to understand. We'll start from understanding what all features are here, like which features are the redundant ones, and which is that one feature that we actually need to predict. So from here we'll be seeing all this. See, that these are the name is for the name of serial. MFR stands for manufacturer of serial, and all these things. Type is for whether it is of cold or hot type. Calories per serving, all these things are over here too, and this is the acknowledgement. So you can download it either from here or from here. So any is fine basically. So in this today's session, what we'll be doing is we'll be taking off some really basic concepts of the same, and we'll be doing a mini project on it. Thinking that linear regression or regression is something that everyone understands, and even if you don't, I'll try my best to explain a bit because of time constraints, I won't be able to explain it with that stretch. But I believe everyone will be able to understand that. Now let us start with it, and also I'll be sharing the link to this Colab notebook that I have made, so you'll be able to access it too. So first of all, like, am I audible? Okay. Great. So I've shared in the comment section only. I'll share it again. I'll share it again. Have they received it? That would really be helpful. Thank you. So now let us start with this mini project of ours. I hope you all have received the link now. Type a yes if you have. Okay, so let us start. So basically, this is the dependencies that we are having. One dependency is pandas, another one, there are various other dependencies of this too, but starting off with pandas and numpy. First of all, we are taking pandas because it would help me to get the data frame, to adjust the data frame, like for the data frame centric operations. Over here, you're able to see df equals to pd.read underscore csv. So that is how it is happening. And over here, if I run this, yeah, if you actually don't have all these things, you can simply do it by pip install pandas, and you'll be able to do it with pip install numpy. And where do you have to do it? You have to do it over here. CMD, open CMD, do this. You'll be able to do it. It would show requirement already satisfied because I already have it. And the same would be for NumPy. You can do it in your command prompt. Type CMD in your run in that run section of yours, and you'll be able to do it in no time. So I have it. So no need to do it again. And moreover, if you are doing on Collab Notebook, you actually don't have to have near system only because this Google Collab Notebook has it all. But in case if you are doing it in Spider or something like that, like even Spider has it, so doesn't matter. But still, if you are doing it in some other ID like Python or something like that, in that case, or ideally in that case, you need to have this dependency. You need to install it. So over here, what I'm doing is like this is I'm accessing from a website, but because over here I'll have to like upload the data set, and then I won't be able. It would have been like very hectic thing for me to do. So because of that, I have shared the data set link to you, but I'm accessing the data from a website, which is in the CSV format. So if you'd see, it is the same thing. It's like 100% brand over here, and will be going up 100% brand, 100% natural brand. It is the same thing, 100% natural brand or brand. Okay, great. So what does this function do now? First of all, what we have done is we have taken this df. Df is basically a variable name, and now we are actually doing what? Nothing but we are reading the CSV file, and we are converting that into a data frame sort of thing, uh, and now then we are storing this. Df stands for data frame, and now I'm interested in seeing the first 5 rows of this data frame. So I'll be doing that with df dotted. So have I run that cell? Okay, I have run it. So if I do it, it would be something like this. If I'm interested to see the last 5 rows of like how five, because it starts from 0 to 4, it is five in that sense. So if I'm interested in seeing the last five, so I'd be doing df.tail. So from here, I'd be able to see this thing is there. So this is how you'd be like seeing the first 5 rows, and this is how you'd be able to see the last 5 rows. 1, 2, 3, 4, 5. These are 5 rows, and now uh, yeah, one more thing. So from here, we have understood that I'll tell you. This is how we have taken the data set now. Okay, first of all, you need to understand the concept of continuous and discrete values. Okay, so I tell you, like if I'm supposed to say that my height is 180.2 centimeters. So because that is in decimals, so it would be showing me that it is a continuous value. And if I'm supposed to say to my mom that please give me 2 bananas, so because that is an integral value, it would be a discrete one. So over here, you are able to see that it is quite obvious that we are supposed to predict the rating of all this. Okay, and these are our features from name to MFR type calories. There are a lot of features in that, approximately 14 if I'm not wrong. So yes, if you want to see how many features are there, there is one simple thing you can do. There are various things, by the way. So what you can do is like write df.shape, run it, and then you'd be able to see 77, and then there are 16 features. 16 stands. This is in the format of row comma columns. So 77 rows are there and 16 columns are there. So if you would count, it would be a sum of 16. So so as I've just said, independent. Sorry. In this continuous and discrete variable, a continuous variable is the one where the value is in decimals, like here it is in rating or something like that, or had it been my height or weight, it is in decimals. So it would either in decimals or in the form of fraction, then it would be a continuous value. And if I'm telling my mom to bring me 2 bananas, it give me 2 bananas to eat. So because that is an integral value, 2 is an integral value, so it would be a discrete value. So when it comes to machine learning, it is really important for us to understand that we use like for us to train all those machine learning algorithms, we need to have our values like in the form of numbers, irrespective of the fact that they are in decimals or integers. We just want them to in the form of numbers. We need to see those digits. So we are able to see that over here they are not in the form of numbers. So we'll be dealing with them in some time. I'll tell you that also. So over here we need to understand one more concept. First of all, I need to ask: am I going fast, or you all are able to understand what I'm trying to say? What I'm trying to say. Type a yes if my pace is okay. If I'm going fast, just type it like you are going fast. So I'll be pacing a bit down. Uh, okay, I think that I'm okay. So, from this, what we'll be understanding is that there is one more concept of dependent and independent variable that we need to understand. So let us take one case where I'm preparing for my exam, and the marks of mine are like my result depends on the number of hours that I invest into studying that subject or studying for that interview or something like that. So over here, uh, my result is dependent on the number of hours I'm studying. So over here, my number of hours in that section would be called as a dependent variable, because the result is no the result is the dependent variable, because result is being dependent on the number of hours that I'm investing into studying. So the number of hours that actually I put into studying is an independent variable. So similarly over here, we need to understand that the rating that we are having is dependent on all other factors, all other features that we are having over here. So, but at times it happens that we need to understand that not all features are the ones which are actually affecting this independent, like dependent variable that we're having. So at that moment of time, it is very, very important for us to simply remove those features. Like uh, just because a name is 100% brand, that doesn't really mean that the rating would be 100. So simply like that, if there would be like another like a product idea or something like that, it is not really affecting or impacting the rating in any way, because it really doesn't affect what the rating of this actually is affected by the ingredients that we are having in that thing. So that will be seeing that in the coming time. One more thing that we really need to understand, that is over here, as I've just said, name is really not impacting the rating in any way. So we'll simply be dropping that column out. So what we can do is we can just drop this column out, whichever column which we actually want. We can put it up into a list, and then we can simply do that. Here access stands for access equals to 1 stands for that column. So it's a column. So if I'd be running it, I'm done with that. So over here, what I have done over here is this particular set of code I'll be explaining it up. Over here, it is if you see the self section, here I'm able to see 33333. Okay. Uh, I'm able to see had if it hadn't be there, then I would have got into a confusion that whether all those values are 3 or not, or something like that. Or it's like if every value is 3, then I can drop this column also, because I can. It is quite evident that all other values are changing, because previously I haven't done this thing. I was able to comprehend a rough idea about the column that I actually want to drop is from by seeing this thing, the df dot head, the first 5 rows that I'm having. So over here, all these values are 3. So just to confirm that if that been a case where all those values would be 3, then I would have dropped this column too, because if every value is that if every value is same, then definitely it is not impacting. So what I did here is like I typed the code where I'd be getting the unique values. over here. And the special functionality of set data structure in data type, I would say, in Python is that it just avoids the repetition and would show you the unique values that it is having in that specific series. So it shows that there are three different values. So that is why I thought, okay, let us keep it up for the time being. Now we'll be coming up to sklearn.preprocessing.label encoder. So previously I said that it is really very important for us to understand that we need to have all those values in the form of in form of numbers. So over here we are having these characters over here in between. So we need to understand how these characters are actually impacting. So just for the timing, we'll have a look what all these characters are there for. A is for like, okay, we are able to see it from here. I've also shared the link over there, so you'll be able to see. So what I've done over here is that I know that the first two column of mine. See, when I have removed this name, for uh, initially this was index 0. If I'm talking about column, this was index 0, this was 1, this was 2. But when I have removed this, because you saw that I have just dropped that column right in front of you. So when I've dropped this column, then this becomes 0 and this becomes 1. Initially, name was 0, index 0 was name, index 1 was MFR, which is like manufacturer, something like that. Type was index number 2. But since I have dropped the name column now, so manufacturer becomes index 0 and this becomes index 1. So simply you can relate it that there has been a queue where if this is removed, then this becomes 0 and something like that. So you'll be able to correlate things well. So now what label encoder does is it encodes the values. So over here, this G would be encoded in some other value. C would be encoded for that specific column. And how does that encoding is happening? It is happening in an alphabetical order. So if you'd be seeing over here, it is arranged in alphabetical order. So A would be encoded as 0, G would be encoded as 1, and after A would be G. Okay, yeah. A would be encoded as 1, this would be 2, this would be 3, 4, 5, 6. So we are having 6 categories for this column and we are having 2 categories for this column. Over here, if you would see, code, the C letter comes before the H letter. So C would be encoded as 0 and H would be encoded as 1. And that is how things would be there. So what we have done is like actually we have encoded it up. uh, we'll be encoding it up. So this is the class for encoding, and we have like we have created an object. So now it is the time for us to like we'll be doing this in a while, but before that we need to split like segregate the data into dependent and independent variable. So as I told you that the rating of the serial is depending on the other factors, so it is an dependent variable. Okay, the spelling is wrong. Dependent variable. And over here, x is the independent variable because of which things are varying. The rating is varied. So now this is the data preprocessing step that I'm talking about. Like data preprocessing step also includes like whether I'm having missing values or label encoding. All these things come under data preprocessing. So it is really very important for me to understand that whether I'm having missing values or not. Why? Because it would actually, if I'm having missing values, then it would actually hamper the training process of my model, which I don't appreciate because I don't want my model to predict something wrong. And one more thing that you actually need to understand is that for you to have like a great model for your model, for you to have a model which would be actually predicting in an awesome way, you should have to have like a good number of data along with it. It's like over here we are only having 77 rows. That is not a great number, but over here, okay, it is good for beginners and you'll be able to understand things really very good. It is good for practice. And over here, I'll also tell you how you can like make a model good, even if you are having less amount of data. Even if you are having over here, had if it been 7,000 or 70,000 or something like that, things would have been really very better. But over here, since we are having only 77, then we'll be jumping on to the regularization things, which we'll be seeing. in this session. So over here, I'm able to see that there is no missing values because here it is showing 0, 0, 0, 0 to all. Had if there been a missing value or something like that, it would have counted number of missing values in that specific column and it would have shown over here. So now what I'll be doing is, I told you over here that we have created an object for label encoding and the class name is label encoder over here. And that is how we actually make an object for a specific class. And but what we actually will be doing it over here is that I know that you would have seen that uh, these are the two rows that I actually want to encode, and this is index 0 and this is index 1. And if you know the range function that it goes, if I'm writing over here till 2, then it would be going till 1. So it would be something like 0 and 1. For in range 2, if I'm printing I, it would be printing 0 and 1. So index 0 over here and index 1, that is exactly what I want. So that is exactly what I'll be doing. So over here, what I have done is, uh, yeah. So over here, what I actually have done is, okay, yeah, one more thing that I had forgotten. Uh, what you actually do, like I need to see the chat if they are saying anything. Okay. So what happens actually is that if we are having this dot values, I forgot to tell you because there are a lot of things to tell. This dot value actually does what is like it converts your data frame to a numpy array, and this is what is the role of this dot values. And dot iloc is for locating it like column wise. Over here we are having like a split of like the split that we understand and we see in terms of strings or something like that. Even if we can, it is evidently been seen in array also. So what it does is this stands for I want to have every row, every column in my X, uh, excluding the last one, which is over here. The last one is this rating one that we are having. So we want to have each and every column of ours in our X variable that is an independent variable, excluding the rating one. So that is exactly what we have done. And over here, what we are doing is what I'm actually telling is, if you see there is a difference between a column over here. So sorry, colon over here, and that is because this colon stands for like a range of values that I actually willing to have. Over here in this y variable that we are having, what I'm telling the system to do is I want only and only the last value, and that is the dependent variable, and that was the serial rating, the rating. That is what I want. So over here, what I have done is that it is now a numpy array over here. As you can see, it is a numpy array. I forgot to tell you. I'm sorry for that. Uh, so over here, what I'm doing is like this is how I'd be iterating via columns. So over here, when the value of I is 0, I'm fitting like label encoder is doing its purpose for the first column, like which is of index 0 and which is MFR if I'm not wrong. And the second time when it is happening, it is doing for like the second column, which would be having index 1. And so when I'm printing X, it would be printing something like this, right? So now, if you see carefully, now the first and the second column have been encoded. They no more are characters; they are digits. So if I go back up, you'd be able to see that this is what the scenario was. The scenario was they were in characters, but now what the situation here is, they are in digits. So okay, so now there is one more important thing that I actually want to tell you, and that is for us to understand, like there are a lot of columns over here. There are a lot of features, so it is very very important for us to drop features which are redundant. And what do I mean by redundant or irrelevant? I mean that for prediction, you understand that a specific value, as I've just said, uh, my result would be dependent on the amount of hours that I invest in studying. So over here, the amount of hours that I'm investing in study has some weight. So I'd only be considering those columns which have some weight. So how would I be able to check whether these columns are having, which column is having the maximum weight, or which column is not impacting my rating that much, rating of the serial that much? So for that a situation, it is really very important for you to know the concept of correlation over here. So the concept of correlation over here stands. It's like we need to understand like two terms over here, and the first one is positive correlation, and the second one is the negative correlation. So what do I mean by positive correlation? So if I'm talking with you right now, and over here, like what I'm able to feel is that with time I'm getting comfortable talking in front of you. So with time I'm getting comfortable. So the level of my comfort zone is increasing. So it is a positive correlation. Had if it been different, with time, if my comfort zone, if my the level of confidence would have been going down, then it would have been a negative correlation. Because with like over here, if I'm supposed to say with an increase of y, if x also increases, then it is a positive correlation. If x decreases with an increase in y, then it is a negative correlation. So over here, there is one more thing that we need to understand, and that is there is this one thing that there is this one term which is called coefficient of correlation, which has a range of 1 to -1 closed interval. And what do I mean by closed interval? I mean to say that 1 and -1 both are included. So when the value of that correlation is equal to 1, that means it is a positive, it is a pure positive correlation. And if it is equal to -1, then that means it is a pure negative correlation. uh, if it is 0, then there is no correlation. uh, so over here, what I'm doing basically is I have made like this is how you'd be able to get you'd be able to access that class of Pearson R. So there are three types of correlations. I just don't want to stretch that. I believe that would be a lot of information for today. But just to give you a briefing, there are three types of correlations where like three different methods of calculating correlations. One is Pearson R. Second one is Kendall, and third one is Pearson. So that is how it is. It takes place. So which one would be the better one? So we'd be taking Pearson R because it is simple and we'll be able to do it. And there is one thing that you need to understand, and that is you just simply don't go with Pearson R for every data set. It is like Pearson R is dependent on the mean. The way we calculate Pearson R is dependent on mean. So I'd also be sharing you the first column. So now I really am interested in seeing how is my data correlated, how is each and every column of mine is correlated with the dependent variable y. So what I'd be doing is I have created a list which would actually be where actually I'd be appending all of those values over here, all of the values of the correlation coefficient. As you can see, the values are here are between from 1 to -1 because of the concept that I've had discussed like a few minutes back. So over here, what you need to see is that for I in range, what this exactly means. It is like I actually over here what we did was we simply wrote 2. But over here, I don't know how many. Every time I just simply cannot count the number of columns that I'm having. So what I'm doing is I'm just this would help me count the number of columns that I'm having. And I know if it is 16, then it would go -1. So and it is starting from 0. So it is really very important for me for that. And over here, an additional -1 is here because I don't want to consider the column of y, the rating one, because I have already considered that as y. I'm taking it separately. So I don't want it. So over here, as the loops would be iterated, the value of I would increase. As you can see, it is 1 now. And so what we'd be doing is like it would be finding the correlations between that specific column with the rating. And over here, you can see the first column, or like it would be like index 0, the correlation coefficient of index 0. The first column with rating is 0.14. The second one is 0.20. So it is like if the manufacturer is 0, so it is not that much dependent or that much correlated. But this is the type, whether it is cold or hot, is more correlated with the rating than who has manufactured it. So it is really very important. It gives us some insights of the data. and this is how we actually calculate it. And I have calculated this correlation coefficient for that specific column, and it would be changing for it would be changing every time as and when the loop would be iterated. And now what we'll be doing is like we have printed this out, and this is what the outcome would be. So here we can see that this column is uh, it is like it is highly correlated when I'm comparing it with others. And this is also highly correlated. But over here, since it is a negative sign, then that means it is negatively correlated. And over here, it is positively correlated. So over here, uh, what I've done is I've also printed this out. Like I have printed this correlation. I'm sorry, there's a spelling mistake, but nevertheless, we'll do it. So if we just run it up over here again, so we see all this. So now it is really very important to see which column is it is very important for us to see a basic visualization of all these things. So what we'll be doing is we'll be plotting a graph over here. So if you want to see, I have had told you before also, if you are doing it in this in Google Colab or Spider, something like that, then there is no need for you to download this from like install this package because it would be pre-installed. But if you are doing it on some other IDE or something like that, then you would have to do it. I have shown like you have to go there in the command prompt. You need to write CMD and then write pip install numpy pandas or pip install matplotlib, whatever that is. So now we'd be printing this up. We'd be seeing what kind of things are there. So over here, what I'm able to see is that we are printing different correlations, like correlation coefficients over here. So it gives me a brief understanding of all these things, like uh, which one is negatively correlated, which one is positively correlated. So over here, I'm able to see the column with index 2 is negatively correlated. Okay, which I was able to see from here also. 0, column 0, sorry, index 0, index 1, index 2, which is index 2, that is the third column. So first column, second column, third column. So I'm able to see the third column is negatively correlated. Okay, the same for all these things. But it is not giving me a good idea of the exact values because I simply cannot have a scale. I simply cannot sit with a scale and see all these values. So there is one more function that we are having, and that is of plt.grid, which would actually be making a grid. So I hope you're able to see this grid in the background where all these lines are there. So it would be able to, I hope it is giving you a better idea. Like now we are able to see which, like my dependent variable, I simply can skip them because they simply won't be adding that much value as compared to the ones who are densely correlated. So what I'd be doing is I'd be taking those columns out. I'd be taking those columns out, and what I'd be doing is I have taken this index list, which would be for appending the index values of the columns, which are whose correlation coefficient lies from 0.29 to minus 0.29 because they are less correlated. Well, this is not the same everywhere because every data uh, this condition differs from data set to data set. Had if there been like a considerable like a dense data set, then it would have been from zero point 0.4 to minus zero point 0.4 or something like that. So you can with experience you'll be able to decide what would exactly be the right one for her. So over here, if those buildings and those like troughs and like trough is not the right word, but if those heights and depths would have been a bit more considerable, then we would have changed this from 0.29 to maybe 0.40. Or if they wouldn't have been that deep, then we might would have gone to like something like 0.15 to minus 0.15, something like that. So it differs from data set to data set. So over here, I'd be running this, and it would actually be giving me, it is a simple if condition. Over here, if you remember, this correlation list is of the one which is having all my correlation coefficients of the same. So over here, I'm just printing out, I'm just appending those values which are not falling under this condition. Sorry, which are falling under this condition. So if this is the condition, then I'm just taking them into this one list which is index. So now what I'm doing exactly is like I as I've just told you, we are least interested in having those columns with us which are not adding that much value to my result. So we would simply be just skipping them. So uh, what we'd be doing is we have taken these. This is the index of all those columns which are falling under this category, whose correlation coefficient falls under this condition. So what we'd be doing is we'd simply be taking these columns out of that. See, the list is indexed, and we are just adding them into this drop column. So whatever index that we are having, we are just dropping it over here. We simply would have just simply substituted over here. That wouldn't have affected anywhere else. So what we are actually doing is, but over here, the main aim of R is the index that I'm having over here. I want the name of that column. So 0 is MFR. I just told you about that. We just have dropped that column of name because simply having name is not affecting it anyway. Just because the name is Parle-G doesn't really mean that it is a good product or it is having a better rating. So over here, that is the same. So over here, we have seen that index 0 is MFR, 1 is type, 7 is carbo, and all these things. So there are six columns. We are having six columns over here too. So six indexes and six column names for six indexes. And now what we'll be doing is, you would have seen over here what we had done is like we had dropped that name column in this fashion because we had only one. It is also a list. If you look over here carefully, it is also a list. So we are just following the same fashion. We are dropping that column. We are dropping those columns in the same fashion. Over here, you see it is a list again, and we are dropping in the same fashion. We are dropping uh, via a list again, and it is like it indicates like a drop this column wise. So now when I want to see the first five rows, so now you won't be able to see these six columns because we just have dropped them. So now what I'd be doing is I'd be taking this again because now I have dropped them. The earlier value of x was with this because uh, it had all those six columns too. But now since we have dropped it again, so we need to override that. Or you could have simply saved it on another variable. That would have been easier. But it is just a thing to be understood. So as I've just said, this value is for it is converting that data frame into NumPy array, ND array. So now when I'm just printing this independent variable x, we are able to see 70, 120, 70, 50, 110, and those same values are here too. So now I'm able to see that those six columns have been dropped, as I've just said. So it is 77. So like 77 entries are there, 77 rows are there. So now it is really very important for me. Now I'm having a better data. Uh, there is one more thing that I just forgot to tell you about Pearson R. You could have chosen for you could have chose for Spearman or Colonel Taube. But over here we have chosen Pearson R because we are not having any outliers in this. I know we don't have any outliers. What do I mean by outlier? By saying outlier, I mean that we are not having any unrealistic values in that. So Pearson R is very sensitive to outliers. But over here we are not having any outlier. That is why we are using Pearson R. I think I have told this, but just to be doubly sure, I said it again. So uh, yes, we'd be splitting it into test and train set, and now what we'd be doing is we'd be fitting it then. So over here you can simply model underscore selection. Earlier it was cross validation, but now like with updates as documentations are being updated, it has now changed to model underscore selection. And from that we are calling up the class train test split, which actually splits the data set uh, uh, into the given number of parts, like in two parts with I'll explain it. So if I'm having 10 rows and if I'm writing I want uh, my 20% data for my testing and 80% data for my training part. So what I'll be doing is I'll be saying test size equals to zero point 0.2. Zero point 0.2 is for 20%. One would have been 100%. And over here, we need to understand that train size plus test size equals to 1. So it is like 80% plus 20% would be giving 100%. We simply cannot have a data, we simply cannot have the number of rows more than 100% because that is quite obvious to understand. And over here, what we are doing is like, we are just naming those variables. Like I want x train, x test, y train, y test. So the value of over here, see, if I'm breaking it into the test size of zero point 0.2, so what I'm doing is over here is we'd be taking the x train part, like the first row would be in x train, and the ninth row, because I have taken the 80% part over there, so the ninth row would be in x test. Similarly, for the y10 and y part, the first row of the independent variable y would be in the y train, and the ninth row of the dependent variable. I'm really very sorry. The first and the ninth row of the dependent variable would be in y. So that is how we do. This is the train test split, and we are splitting it for x and y. This is for like the independent variable and the dependent variable that we have. So now fitting the model, now what we actually do is there's a difference between simple linear regression and multiple regression that I actually want, multiple linear regression that I actually wanted to tell. So over here, if I'm an employee and I'm going for an interview or something like that, and my salary, if my salary is dependent on simply on my experience, only on one factor, and that is experience, then it would be then that would be a case of simple linear regression, because only one factor is impacting my result, my salary, the result, I mean my salary. But had there been other factors like where do I come from, or number of years that I've, like my experience, or my previous company, or the number of projects that I have done, or any other thing, any other open source things that I do, so in that case it would have been a different story then. So over here you are able to see there are more than one factors that are impacting this rating. Even if even after we have dropped 6 columns, we are having more than one factors that is impacting our rating. So what we'll be doing is we'll be calling it as a multiple linear regression. So in that case, how we do, it's like you're just simply fitting it up in just 3 lines of code. You're just simply fitting your data in just 3 lines of code. Over here, what we are doing is we are just calling this linear regression class from sklearn.linear underscore model. So what you can do is you can just see that this scikit-learn thing over here, I'll just be copying it, and I'll be pasting it in the chat section so that you'll be able to see. Uh, are you able to, did you get the, okay, previously also you weren't able to get it, so I'll just be sharing it up there. Uh, Other times, can you please just share it in the chat section? Okay. No issues. So now what we'll be doing is we'll just be fitting the data up. So I think I have not, okay, first need to, we didn't run it up. So we'll just, else it would have shown some error. There are a lot of things really that you need to keep in mind, but it is not tough. If you simply just believe in yourself, and if you are inquisitive enough, if you're having that much interest in something, you would definitely would be able to do it. So now we are able to see that I just explained you the concept of test size and train size. The test size over here we are putting it up is like 20% of those 77 rows, which would be to be taking that, which would be taking it up in an integral size, in an integer. So if I'm saying 77 divided by 100, integer of 77 divided by 100 into 20. So So we'd be having 15 rows, approximately 15 rows because we have taken it in an integer form. So we'd be having 15 rows for testing purposes, and 77 minus 15 we'd be having 52 rows for training. So that is how we'd be doing it out. So in that case, now we have fitted our model. Sorry, we have splitted our model, splitted our data set, and now it'd be fitting our model. Uh, so for now, fitting the model, it is really very important for us to understand. As I've just said, it is a case of multiple linear regression because we are having more than one value that is impacting the outcome. So in that case, we'll just be fitting it up. So we have fitted the, and there are a lot of different, there are a lot of parameters that we are having. You can simply check it out over there in the documentation. I've also shared the link where you can see there are different purposes for scikit-learn. It is used for sklearn, is used for data pre-processing. It is used for a lot of things for like linear models, for SVMs, for data like ensembles, for linear discriminant analysis, and all of that is there too. So yeah, basically feature extraction purposes. So over here now I'm interested in seeing. Now I've fitted my model. So now I'm interested to see what would be the score, like how accurate is my model. So it shows it is 95% accurate. So it is, see, there is one more thing. If your accuracy is simply climbing above 85%, then it is an then it is an alarming percentage. Because it is like things should not be that, because it comes under the case of like if it is simply above 95%, then it comes under the case of overfitting. And why has it overfitted? Because we are not having that much data. So overfitting is basically when your model simply generalizes the data. It is like if this is there, then that would be there too. So when overfitting, be that overfitting or underfitting, I hope the audience is clear with these concepts, what overfitting and underfitting exactly is. So what I believe is that uh, in that case, what we'll be doing is we'll be just be regularizing it. So what does regularization means? So just coming back to that, we are able to see, I hope you are able to see, it is 0.95. That means if you are multiplying it by 100, it is showing that your model is 95% correct, which is an absurd thing, because had if it been able to, like, if there is something like a different or an unsuspected data is coming, then my model would simply fail. Because if your accuracy, just keep that up, just note that thing in your mind. If your model is having like an accuracy of above 90%, then it is alarming. You simply have to regularize it, because it should not be that much. There is one more concept of accuracy paradox, where your accuracy might be really good, but simply it could not be predicting things really well. So in that case, it is called accuracy paradox. Now I need to now what you need to understand is the concept of regularization. Regularization basically means foundation. So a model which is an overfitted model is like a is like a spoiled brat who is not listening to his mom. You know, so for his mom to like make sure that his kid is not spoiled more, it is really very important for that mom to put that kid under constraints. So regularization basically means adding constraints or restrictions to the model. So what we'd be doing is uh, we'd be uh, restricting the model. And there are basically three ways of regularizations in linear regression. Uh, it is lasso, ridge, and plastic net. But elastic net is more like you need to understand L1 and L2 regularization methods also. It is also very important when it comes for like interview point of view. I'll also be sharing this. You'll get the links to this blog also, and I hope someone will be sharing them. So over here, you just don't need to read this. You just have to see what this over here. Just don't get scared with this mathematical part of that. Over here, the basic difference between the ridge and the lasso is this part that is being highlighted. In lasso, carefully, it is of uh, the the power over here is 1. Okay, the degree is 1. Over here, if you'd see, it is degree 2. So the L1, L2 is decided by the degree. So if the degree over here is 2, then it is L2 regularization. If the degree is 1, then it is L1 regularization. That is simple. So that is what the thing is. Now I'll be coming back. So what we are doing is we are just taking this ridge one because it is better because it is having a degree 2 over here. If you'd see, right? So we'd be doing it with the ridge regularization. So now there is one more concept of alpha. Alpha can, in layman terms, if I'm supposed to say what alpha basically is like, how much constraints if you are having. If the kid is spoiled, then how much restrictions the mom is having on that kid. It's like had if it been zero, then it is like it is the previous case only. So if it is zero point 0.5, then that means the mom is now becoming a bit strict. So and one is like okay, the mom is seriously strict and is really very serious about that kid. So that is how like the more the value of alpha, the more regularized it would be, the more restrictions the model would be having. So over here, before that, we need to see that we are calling this predict class, which every sklearn like has every sklearn algorithm. Every algorithm under sklearn has this dot predict method, which would be actually be predicting your y value. So I have like if you remember, we are having 15 rows that I have said approximately 15 rows in our test section. Okay, over here it is showing the shape size 16 comma 8. Okay, it might have taken the floor value and not the ceiling value above there. No worries. So in that case, what is happening is that I'm having 16 different ratings for 16 different values over here. So what is happening is now I'd be putting in some regularizations on the same. And since I'm having that regularization, now I'm able to see the score that I'm having now. My accuracy score has fallen down to 82%. Earlier it was 95. Now it is becoming a bit better. Now it is becoming a bit better. Now just to see if I am having an alpha, a restriction which is less than 1, but it is still more than 0, then how it would be impacting it up. So if I'm running this, I'm seeing it is having an accuracy of 91%. Then that means it is definitely is regularizing it up. So now I'm able to see there's a difference. Now, this is the last thing of this session, and that is if I'm having a regularization more than other cases, then I'm able to see 65% of it. So simply, it is like it is how you can simply choose the right way, like what would be the value of alpha. At times, it is like you simply have to see where it is going. Like the dip is like too much now. Now you're able to see that if I'm having the alpha value of 2, then my accuracy has approximately fallen by 18%. So it is a considerable fall. Earlier it was from 91 to 80, it's like 9%. Now it is 18%. It is an alarming rate. So it is really very important for me to understand that 1 is okay. Value of alpha equals to 1 is okay. And the rest, if you can simply yeah, you can definitely be having like decimal values into it. 1.25 can also be there because you saw that 0.5 worked. So 1.25, 1.3, 1.5 would work too. You can check that out by yourself. And even if you can try this out with different algorithms too. If you are taking like an ensemble method, like a decision tree classifier or a random tree classifier, or from XGBoost classifier, like not classifier regressor. I mean, I'm sorry, like decision tree regressor, random forest regressor, XG boost regressor, or ADA boost regressor, something like that. Other regressors you can definitely try and see them. And this was it. And I'd now be switching to see if there are any questions. You can ask questions if you are having any. Any questions? Okay, I'll just read it up. If you're having any questions, you can surely ask. One more thing, I'll also be sharing the link to this so that you'll be able to the link to this collab so that you'll be able to access it up. I'll just be sharing so that you'll be able to see. You'll be able to access and you'll be able to run it out by yourself. Okay, so I think there are no issues. Uh, okay, Kiran has asked something. Is there any way to figure out which model will fit? It actually depends. You can simply, as a beginner, I would say you can simply try it out by switching models because it may so happen. It is like it is not always that uh, better models like random forest or something like that would simply be giving us better accuracy. It is like there is one concept which actually showed that if we're having a lot of data, a simple linear like a linear model like of linear regression model can simply outclass like or simply can stand a shoulder to shoulder to like a decision tree regressor or a random forest regressor. So it actually depends on that amount of data that you are having. You can always try it out again and again. It won't take. You just saw that it is just of like you just need to write 3 lines of which you need to change only one line because the rest of the two remains the same. Of that is of dot predict and like dot fit regressor dot fit. It remains the same. So you can always try it out. Is there anything else that you want to ask? Any questions? So I think other than to we are done. Or is there anything else that you want to do? That's great. Thank you for having me, guys. It was a great session. I really enjoyed it all. And